We are now going to take everything we've learned so far and start balancing equations, also known as solving for a variable. So figuring out what is our variable, what number does it represent. So first, we can think of an equation like a balanced scale, and we already talked a little bit about that. So an equation is when you have two expressions that are equivalent, and you always need to keep the scale balanced so that the expressions are equal to each other. So before we start writing expressions, let's just look at these pictures of these scales. So what will it take to balance the following scales? So to balance means to keep them level. So we see this first one's level, this one is not level, and then it's level again. So we start off with 4 cubes on one side and 4 cubes on the other, and it's balanced. Our scale is balanced, both sides are equal. So we can say that our expression 4 is equivalent to the other expression, which is also 4. And now it becomes unbalanced in this middle example. We have 4 plus 5 more. And now it's unbalanced. So what do we need to do to keep it balanced? 4 plus 5 equals, we need to add 5 on the other side to keep it balanced. So if we are adding 5 blocks to one side, we must add 5 blocks to the other side as well. We must add 5 blocks to the other side. Keep those scales balanced. So I'll let you do this next one, but moving down, what about here? Yeah, let's actually look at this last one down here. You guys can try this one on your own. So this last one, we have an array that looks like a 3 by 1, 2, 3, 4, 5, a 3 by 5 array, and another 3 by 5 array. And they show that they have split it into 1, 2, 3 groups. So they have taken 15 and divided it by 3. But over here, we still have 15. So right now, these are not equivalent. You can see they are not balanced. So what we did is, if we took this 15 and divided it by 3 on the left, then we also needed to take the 15 and divide it by 3 on the right. So if we divide one side by 3, we must also divide the other side by 3. So, how does the idea of a balanced scale help us to solve equations? What happens when we have actual number sentences written out, like 5 plus 3 equals 8? Or when we have a variable in there, if we have b minus 7 equals 12, how does that help us? Let's find out. So we have a balanced scale here, and what we're going to do is we're going to write an algebraic expression for the left side of our scale. So I'm just going to write what I see there. So I see this trapezoid that has an x on it, so x, and then I see 5 blocks. So that's x plus an additional 5 blocks. And they are showing that it's balanced, so it's equal to everything on this side. We can see a balance. So x plus 5 equals, and it looks like we've got a 3 by 3, so that's 9, plus 1 extra is 10. So our equation our equation is x plus 5 equals 10. So now we're going to think about, okay, how can we keep this scale balanced while also figuring out what x equals? If I could see a scale that just has x on it, then it'll show me what x is equal to on the other side. So what happens here? We still have our 10. What did they do here? We took away 5 blocks. So we want to take away 5 blocks on the other side as well. So what do we need to do to the left pan in order to get x by itself? We took away, so we subtracted 5, which means we are going to balance the scale by subtracting 5 from the other side. They also call it a pan. It does kind of look like a pan. So subtract 5 from the other side. So then when we finally have our balanced scale, we see that x has to be equal to these 5 blocks. So our balanced scale shows us that x equals 5. And we can check our answer by taking 5 and substituting it back in for x. So if I take my 5 all the way up here, is 5 plus 5 equal to 10? Yes, it is. So you can always substitute the value back into our original equation to make sure that x is actually 5 and that it works out.